So as promised, we're going to finish up the last little bit of information that you kind of need for your project, and that is going back over regression. We've done linear regression, where we take data and we find the line of best fit that goes in a straight line through the data, trying to touch as many points as we can so that it can model the data. And now we want to apply that to quadratics as well as linear. And quadratics, you know, are parabolas. So a lot of times in real life, what we're talking about when we do quadratics is things that are falling. Gravity happens to be a quadratic model. And so things can go up in the air, but anything that goes up has got to come back down. And so it usually makes these lovely little parabola graphs when you are doing the data. So if we are going to do a regression problem, let's do an example. Now, this is the sheet that you have on your Edmodo, so if you just want to pull it up or print it off so that you can use it as you're going along, that'll be great. Pumpkin tossing, or pumpkin chunkin', was it? Pumpkin chunkin'. A pumpkin tossing contest is held each year in Morton, Illinois, where people compete to see whose catapult will send pumpkins the furthest. One catapult launches pumpkins from 25 feet above the ground at a speed of 125 feet per second. The table shows the horizontal distance in feet the pumpkins travel when launched at different angles. Use a graphing calculator to find the best fitting quadratic model for the data. So if you remember from linear functions, on our calculator, to put data in, we have to go to Stat and Edit, and then we can put all of our X values in the first column and all of our Y values in the second column. So we've got 20, 30, 40, 50, 60, and 70. And then I have to come over and I have to put in my Y values, 372, 462, 509, 501, 437, and 323. Now, let's say you don't have a graphing calculator at home. Don't use that as an excuse to not do these regression models. There are tons of calculators out there online, folks, and we have used one for our linear project. If you remember, a spreadsheet. All a spreadsheet is a calculator. So 20, 30, 40, 50, 60, 70. You can put in your data just like you put it into your calculator. Let's see, 372 and 462. 372 and 462. 509 and 501. 509 and 501. And 437 and 323. So if you don't have a graphing calculator, by all means, use a Google Sheets, and you can still figure out what your regression is. Don't forget, for regression, we quit, and we go to Stat and Calculate. Now, previously, we did linreg. Well, now we want to do quadreg. And so when we do quadreg, we're going to end up with our equation. If we're doing it on the spreadsheet, don't forget that you have to highlight the data, and you go to the chart. You're going to insert a chart, and you have to go through actually making the whole graph. So do a scatter plot. Oh, look at it. It looks like a nice little parabola. We can make sure that we customize it and give it all the information that we want, but we're not really interested in how pretty it looks. We just want to make sure that we do a trend line. But instead of doing linear, we want to do a polynomial. And then we do want it to show us the equation. So show, label, use equation, and then it's going to give us that x squared value as well. So if you don't have a graphing calculator, you do have other options, but that's just something to think about. Unfortunately, on a test or a quiz, you can't use a computer. So a graphing calculator is really your only option. So you're going to have to make sure that you do know how to use this on a graphing calculator. So now we have equation to go with our problem. So as we look at the rest of these questions, step one, enter our data into toList on the graphing calculator. They want us to make a scatter plot, so we can look at the scatter plot. That's what this is. Notice it's not necessarily telling us that we're turning this in. We're wanting to look at it and see what it looks like. We wanted to use the quadratic regression feature to find the model for a data, and then we want to check how well the model fits the data. And so you can look at it a little easier actually on the spreadsheet and see how well it actually fits, and it actually fits pretty good. Let's notice that it actually gives us pretty close equations here for these, but this one did calculate it a little differently. So you want to make sure that you know, on a test or a quiz that you do know how to do this on a graphing calculator. When I put this in my calculator, notice that if I write down the equation from the calculator, it's y equals, and then they give me a, b, and c. So I get negative 0.27 x squared plus 23.21x plus 13.6. And so I can actually graph this in y equals on my calculator. So if I go to y equals and I type in negative 0.27 x squared plus 23.21x plus 13.6 and graph it, it doesn't show up very well. If you go to zoom and go down here to the bottom, there is a zoom stat. And what that'll do is it'll help things fit our data. If we have to go to stat plot, you can actually do the scatter plot as well. If you go to the first stat plot, you can turn the stat plot on. You can tell it that you want a scatter plot. Our data is in list 1 and list 2. You can tell it whether you want like these big dots or you can do little dots. Some people like to do the plus marks. I kind of think that looks kind of cool. And then go to zoom stat. And then it will actually put all the points in there, and you can see how well it pretty much hits all of those data points. The calculator has a lot of functionality for you, and we want to be able to look at our graphs. Because now that I have a graph on my calculator, think of all the things that we have done over the past few days. We have found maximums and minimums, which are questions on your project. And so we now know if I have an equation in standard form, how do I find my vertex and my maximum? If I'm looking for where y is equal to 0, the x-intercepts, I know how to find those using the second trace option on my calculator. If I'm looking for the y-intercept, I know how to plug in 0 for my x's to find my y-intercept. All of those things have an application in real life, but once we've used regression to find that equation, all the things that we've done over the past few days to find x-intercepts and y-intercepts and vertices and maximums and axes of symmetry, these are all things that don't change just because the equation has a decimal in it. All of those rules still apply.